Let a of t equals 6t plus 3, and v of 1 equals 8, and x of 0 equals 8. So it's giving me an initial, not really an initial velocity, but velocity at time 1 is 8, and then the position at time 0 is 8. So the first thing you need to do is figure out what the velocity is, and I'm going to do the antiderivative of acceleration. So v of t equals, and then I'm going to bring the coefficient down, but I'm going to add to the power, divide by my new power, add, divide. That 3 is really a 3t to the 0, so it becomes 3t to the first, divide by 1, plus c. So this velocity is, that's not what I meant to do. Okay, so I have velocity equals 3t squared plus 3t plus c. And then I know that v of 1 equals 8. So I have 8 equals 3 times 1 squared, which is 3, plus c. So I have 8 equals 6 plus c. So c equals 2. So my velocity equation is 3t, v of t equals 3t squared plus 3t plus 2. Now I need to do this again to get my position function. So I'm going to erase this. And then I'm going to do the antiderivative of velocity to get position. So my position equation will be x of t. So I'm going to bring the coefficient down, add 1 to the power, divide by my new power. Bring the coefficient down, add 1 to the power, divide by my new power. Bring the constant down, add 1 to the power. It was t to the 0, now it's t to the first, divide by the new power, plus c. So my position equation is x of t equals t cubed plus 3/2 t squared plus 2t plus c. And then I know x of 0 equals 8, so I would plug 8 in for the x of t and 0 everywhere else, and that means c equals 8. So my position equation, I'm not going to try to write it up there, is t cubed plus 3/2 t squared plus 2t plus 8. So determine the position of the particle at t equals 2. Well, that's just x of 2. The x value at time 2 is 8, plus, and then 2 squared is 4, times 3 is 12, divided by 2 is 6. 2 times 2 is 4, plus 8. So I have 8 plus 6 is 14, plus 4 is 18, plus 8 is 26. Now notice that that's x. My x value is 26. That kind of implies that we are on the x-axis, which means the y value is 0. If it didn't ask for the point, which this one didn't, you could write x of 2 equals 26. Right? When is the velocity increasing? When the velocity is increasing, that's when the acceleration, the slope of velocity, is positive. So I'm going to look at my acceleration equation, which is the one that was given to me. So I'm going to say 6t plus 3, and I'm going to set it equal to 0. Subtract 3 from both sides. And then divide by 6, so t equals a negative 1/2. All right, so this one, I did not write x greater than equal to 0. But I'm going to, on the slides, and just this, not x, but t greater than equal to 0, I'm going to go add that. So t greater than or equal to 0, because we do not have negative time. So this implies that there's some time going on. There's not negative time, so we are going to ignore this. And I have a number line from 0 to infinity out there, and it's for acceleration. So I need a test value that's in there. I'm going to pick the number 10. I'm going to plug it in to my acceleration equation, and I get something positive. So it says, when is the velocity increasing? That's when that entire interval. So I would say from 0 to infinity. And the justification is a of t greater than 0.